Hello and welcome to another lecture from my class, Psychological Testing and Assessment. And as usual, we're beginning with a webcomic from the excellent webcomic series xkcd.com, which is funny and maybe a little bit of a reminder about the ways in which intelligence, mental ability, similar terms, carry with them a value judgment, or at least they can sometimes carry with them a value judgment, and we need to be mindful of this. Now, I've talked about this idea of adding meaning or in other ways reifying constructs throughout much of this semester, but it's worth a quick reminder at this point, because in this lecture we'll be transitioning from a rather general discussion about intelligence or mental ability to a more specific and focused discussion of some of the major current theories of mental ability and some of the ways that current tests of mental ability enact those theories or put them into practice. So again, this is a kind of a continuation of a previous lecture. I'm still talking about mental ability, and I'm talking about ability testing. So to put another way, I'm talking about intelligence testing. I'm going to review some of the current, or well, most of them are current theories of intelligence or mental ability. You can see them on the slide here. And then I'm going to talk about both the Wechsler scales and the Stanford-Binet scales, because these are the most commonly used measures of mental ability or intelligence. I'm going to give an overview of each of them. Now, in my class, we're focusing on the Wechsler system, so I have posted on our Blackboard site already, as I'm sure many of you know, a link to Pearson Psycor's training video for the WAIS-IV. So if you haven't already watched that all the way through, please do so now. This lecture will give you a bit of an orientation to that material. Quick point here, intelligence or mental ability. Now this word and this phrase are kind of synonymous, and truthfully I'll probably flip-flop back and forth between them as I talk in this lecture. The way I see it, intelligence is certainly a more familiar word, but it can be value heavy. Values about how important someone is, how good someone is, what someone's potential is in life, generally speaking, are kind of snuck in when we talk about intelligence. Not always, but often. I mean, seriously, if somebody said to you, your child is not very intelligent, that's something that might have a certain emotional impact in a way that wouldn't if they were talking about some sort of other psychological construct. The word mental ability is somewhat more technical because we're talking about people's ability or abilities to do certain types of mental work. It's also more abstract, I suppose, at least in the sense that most people probably don't know exactly what you mean if you say the phrase mental ability. I would argue it's generally preferable to use the word mental ability, especially for real clinical work, because of the fact that it's less value heavy or value laden. And also, I think, because it prompts an important question. If I say mental ability, you should think mental ability to do what? And that should focus you or remind you that we're talking about not all abilities that humans have, which are, of course, many and varied, but specific types of abilities, especially those that are related to abstract thinking of the sort that commonly is done in school settings or when doing the type of work that school prepares you for. And none of that is to discredit or really minimize the important contributions that theory and test development for mental ability testing have made in psychology. I mean, I think it's amazing and fascinating, but it's to just gently remind us that we're talking about something somewhat more specific than general intelligence in a very broad and vaguely defined way. Okay, so let's look at some current, well, most of them again are current theories of intelligence. I said most of them are current theories because actually, to begin, I'm going all the way back to Galton and Cattell, who you may or hopefully will recall originated a particular theory of intelligence. See there, I'm flipping back and forth between intelligence and mental ability already. A particular theory of intelligence that is we associate with the so-called brass instruments era of testing. And here the idea is that intelligence is related to sensory abilities, or maybe also to kind of nervous system efficiency. and people who are more intelligent or more mentally able have more keen sensory systems and more efficient nervous systems, and thus they're able to get more information for the world and do more with it. Now, as you know from previous lectures and from your reading, or perhaps even from other classes, the real knock, or the kind of the Achilles heel of this theory and the associated approach to testing, is that the results of testing for things like sensory abilities and sort of mental or nervous system efficiency were largely uncorrelated with measures of achievement, things like how well people who were tested were doing in school or how successful they were at work. And because of this sort of lack of predictive ability or predictive validity, I should say, history has largely abandoned the whole idea of intelligence as mental efficiency and sensory acuity. I say largely abandoned because in truth there are modern efforts to understand how mental ability may be related to speed of processing. I mean, there are in fact, of course, processing speed indices on most major current tests of mental ability. So there's this general idea, I suppose, that if you're a rather mentally able or rather intelligent person, you can do certain types of things quite quickly as compared to someone who's less mentally able or less intelligent. And to be more precise, there is research on which is sometimes called chronometric analysis, which is just looking at very finely tuned measurements of reaction time. And so what's interesting is to note that some of these measurements of things like reaction time and movement time are correlated modestly or better than modestly with intelligence testing results. So maybe there is something to what Galton and Cattell and others way back at the turn of the 20th century thought. Perhaps they just didn't have the right instruments to either measure those differences or the right other measures of intelligence to use as criteria for intelligence. Maybe we do now. It's kind of a new area of testing. That said, though, it's something that we're not going to talk about much more than I have already in this lecture and in previous lectures. And an important and maybe rather general point to make at this point in the lecture is that after the brass instruments era, after the theory and the work of Galton and Cattell and others was largely abandoned, the further development of most theories of intelligence or mental ability involved the development and the evaluation of specific tests of mental ability, tests of intelligence. And these especially were tests that involved stimuli or problems that were presented to participants to solve or to respond to, and especially respond to verbally. So the type of things that we're probably familiar with from our own experiences or certainly from our reading when we think of intelligence tests. I'm going to sit down and show you a set of puzzles or problems. I'm going to ask you a set of questions. You're going to try and answer them. That whole approach to intelligence testing or mental ability testing was what followed largely from the brass instruments era. So the development of these tests and the evaluation of these tests, especially using factor analysis. And I've discussed factor analysis in a rather brief and probably overly shallow way in previous lectures, but you know from those lectures or from other classes you've taken perhaps that factor analysis is a multivariate technique that's designed to help us simplify complicated relationships between large numbers of variables, for instance, large numbers of test scores or even test item scores, so as to represent those relationships in terms of a relatively smaller number of factors. The idea is you could administer one or more tests of mental ability or intelligence to a group of people, examine the interrelationships between responses to different items, and extract a solution which suggests that people's overall responses, or rather the variability in people's overall responses to these tests, is due to or kind of can be resolved in terms of their levels of particular factors. These factors especially being named things like processing speed or memory or verbal ability or so on and so on. I tried to represent this pictographically as kind of a circular cycle where the development, people working in this field might develop new tests and administer them and run factor analyses on the results. that would in some way inform their theories, that would guide them to select items which were based on those factors and those theories, to develop new tests which would be administered and then would be subjected to factor analysis, and so on and so on. Kind of a developing, ideally kind of progressive, upward spiraling cycle. An important point or points to make here is that this process, or this kind of intellectual project, which has been going on since fairly early in the 20th century up through today, has revealed a lot about the structure of intelligence, or about mental ability, at least in a factor analytic sense of the word structure. And while this complexity of the theories about intelligence, about mental ability, have expanded greatly as a result of this process, the focus has remained arguably quite narrow on things like verbal and analytic abilities, on school-related abilities and achievement. And you can take that as either a criticism or as praise. It really depends. If you believe that intelligence or mental ability, or at least the parts of intelligence or parts of mental ability that we're most interested in, are these somewhat limited set of abilities, then this makes a ton of sense. If, however, you believe that intelligence involves things like relating to others socially, or thinking creatively, or other aspects of intelligence, then maybe this process has been overly reductive, or has ignored these other, if you think this way, important elements of what it means to be intelligent. Again, it's just worth keeping this in mind as we move forward. And another important point, or maybe important question that you might have is, well, why learn all of these theories that you've read about in your text and that I'm about to briefly summarize in the next many slides? Why learn all of them, especially considering that some of them are pretty impractical, as you'll see later in this lecture? I would answer that question by arguing that it helps to think about major theories of intelligence when you're doing intelligence testing, because it reminds you what intelligence testing is and what it isn't. It is a process that allows you to gather information about someone's mental ability or abilities in certain fairly specific domains, or from certain fairly specific angles or perspectives. It doesn't include other types of abilities which may be important or even valuable, like, again, creative thinking, or interacting socially, or solving complex inter or intrapersonal problems, so on and so on and so on. And that's important for you to have in mind, because you need to think about that as, I would argue, as a clinician, when you're doing the testing, when you're thinking about which tests to select for a particular client, and when you're communicating the results of those tests to the client and to other people. It's common when you sit down with a client and you start to administer the Wechsler Adult Intelligence Scale or some similar test, for the client to ask you, hey, is this a test of intelligence? Now, how do you answer that question? Well, how you answer it probably has a lot to do with what intelligence is, at least in terms of how it is measured, how it is operationalized on the Wechsler Adult Intelligence Scale. And to know a bit about that, it's helpful, I think, to know a bit about some of the major theories which contributed to, or which were kind of influential in the development of the Wechsler Adult Intelligence Scale. Does that make sense? Well, hopefully it does. Because whether it does or whether it doesn't, we're moving on. The first kind of major theory, sort of post-brass instruments era that we encounter, is Spearman's theory of little g. Spearman, as you know, is important in the history of psychology, especially for the development of psychometric theories and the development of factor analysis. He worked with and was influenced by Galton, and he had this idea that the really important thing about intelligence or mental ability is the ability or the capacity to learn relationships, to learn correlations between things in the world, to be able to induce general principles from observed phenomena. And what he did in order to kind of explore this theory or evaluate it was he studied various tests and measures of intelligence, mental ability, and subjected the results of those analyses, when those tests were administered to people, to factor analytic analysis. And from that he extracted a major factor which he called little g, or the general factor, which is sort of thought of as the driver or the power of of mental ability, of intelligence. And beyond that, there were, depending on the number of tests in a particular analysis, multiple specific factors, or little s factors, which are kind of the engines of the particular task themselves. So if that metaphor is maybe a little bit confusing, let's try and represent it pictographically. So let's imagine you have administered 3 different tests of mental ability or intelligence to a large number of folks, and you've observed, of course, variability in the scores or responses that people get on those different tests. Now, some amount of that variability is common across those 3 tests. That's the dark shaded block in the middle here. The blocks are meant to represent kind of variability in sort of a Venn diagram sense. That block, Spearman argued, is little g. It's this common power that all people have in some amount, but all people vary from one another to some extent on. If you are relatively high in little g, you've got a lot of mental power, to use that previous metaphor. You tend to do well on almost any test of intelligence we can give you. If you're relatively low in little g, you do poorly, or you tend to do poorly on almost any test that we can give you. Now, little g doesn't explain all of the relationship here, or all of performance, I guess I should say, because on any particular test, there's some amount of unexplained variance that is specific to that test. Those are the S factors. The particular engine, to use the previous metaphor, that is important for test 1, or test 2, or test 3. You might do quite well on test 3, even though your score on little g is relatively low, because there's something about test number 3 that you're particularly good at, or vice versa, you're particularly poor at. Just another way or attempt to represent this pictographically. You can imagine here we've got 4 different tests which we've given to some large number of people, and of course there's variability on each of those tests. On each on each given test, performance is influenced by both little g and S factors, the S factor that is appropriate to that test. So how well or how poorly a particular person does on test 1 depends on his or her level of little g, and also his or her level of whatever is specific to that test. Now, Spearman argued, and most other people after him argued, that what's really important then is little g, because it's the thing which is related to performance on any test. S factors are maybe important, but they're a lot less important because they are, by definition, specific to just one type of test or just one type of activity. It's little g, which is, again, this general, why it's called g, power which drives all, or at least all, the mental abilities that are tested, performance. And just to further try and represent this pictographically, tests which are fairly highly correlated, let's say you have 4 different tests, again now I'm representing them A, B, C, and D instead of 1, 2, 3, and 4. We've got 4 different tests. Let's imagine test A and test B, different tests of mental ability, are quite highly correlated with one another. Tests C and D not so highly correlated with one another. The explanation there is that tests A and B share more overlapping, they overlap more with their measurement of little g than do tests C and D. So what do we make of all of this? Well, again, Spearman was working with factor analysis, and he used this technique to validate this basic theory that he had about mental ability or intelligence. And he argued, and certainly many people picked up after him on this idea, that the emphasis should be on little g. This is the factor that is influential for all test performance and really should be the focus of test development. The idea is like, this is the thing that is intelligence. It's that capacity or that ability you have, which is going to generally make you quite good if you have a lot of it at any test we throw at you, or quite poor if you have not so much of it on any test we throw at you. One challenge to this theory, or kind of point of further development, was the recognition, though, of group factors. Group factors were an attempt to explain this interesting phenomenon wherein tests of mental ability or intelligence were sometimes more highly correlated with each other than would be predicted merely from their loading on factor little g. Which suggests a kind of a common factor, something that two or more tests would share with each other than little g. Because again, all tests share with all other tests little g. That's why it's little g. It's this common, it's this sort of general factor. But it might be the case that two tests, or two or three tests, might be somewhat more correlated with each other than we would expect, given how much each of those tests loads on little g. What would that mean, or what could that mean? Well, it could mean that there are other things that people have other than just little g, and Thurston picked up on this idea and expanded it into a theory of primary mental abilities. The idea that there's little g, but there are also some relatively specific mental abilities that are related to or kind of fall out of little g, which are important. Now, these primary mental abilities include things like verbal comprehension, which is this ability that you might have which would relate to any sort of task that had to do with vocabulary or reading comprehension or using analogies. There's word fluency, your ability to recognize and use words that would influence your performance on tests like tests of anagrams. A number ability, which unsurprisingly influences your performance on tests of arithmetic. Also things like your space, there's space, a kind of an ability which influences your performance on tests of spatial reasoning, associative memory, perceptual speed, and also inductive reasoning. So if we try to combine or reconcile Spearman's theory and Thurston's theory, we get an interesting hierarchical organization where there's a first order factor, little g, which influences performance on all tests of mental ability or intelligence. Then there are two second order factors, one being a kind of a general verbal educational factor or ability that's going to influence your performance on any task that involves verbal production or understanding of learned material, and another factor which is given the really awkward name practical, mechanical, spatial, physical, which, as you might guess from that very awkward name, reflects your performance or influences your performance on tasks which are not verbal, which have to do with spatial reasoning or concrete operations on objects. Then beyond that, there are these third order factors which are specific primary mental abilities. So we've moved from the idea, just to kind of dial it all the way back, that intelligence is nervous system efficiency and sensory acuity back in the days of Galton, to this idea that intelligence is this one general factor, Spearman's contribution, to a more complicated model that intelligence is a kind of a hierarchically arranged set of factors or abilities that can be ordered, as you see here in this kind of combined Spearman-Thurston model, or Spearman-Thurston theory. So an important point to really recognize here, I think, is that Thurston's work encouraged this more complex thinking about mental ability. It's not just one thing, seemingly at least. It's this hierarchically arranged system that involves kind of general ability, verbal and nonverbal ability, and then specific abilities. You could imagine that your performance on a particular test, just one test, would depend to some extent on your general mental ability, on whether or not that test was a more kind of verbal or nonverbal test, and then anything that is specific about that particular test. So it's this kind of hierarchically organized system. Another important point is that this kind of thinking, especially this idea of kind of a verbal and nonverbal factor, shaped a lot of the development of mental ability or intelligence testing. So the Wechsler system and later the Stanford-Binet system really adopted this idea of verbal and nonverbal intelligence, partly because at least some theories, the kind of Spearman-Thurston theories, suggested that there are, in some kind of real sense, a real structural sense, a kind of a verbal and a nonverbal intelligence, but also because I think for many people commonly just in our day-to-day living, it kind of seems like there ought to be a sort of a verbal ability and a non-verbal ability. She's really good at math. He's so clever with poetry and lyrics. This idea I think we often have when we talk to one another, that they're two sides or two aspects of intelligence. I think that probably clicked very well with both the research and also maybe people's kind of common sense view of what intelligence ought to be. So okay, it's getting more complicated. We're getting hierarchical. We're getting structural. That's cool. Buckle up, because it's about to get a lot more complicated with Guilford's structure of intellect, or SOI model. J.P. Guilford expanded on Thurston's model even more with the idea, or introducing the idea, that mental ability is organized in the sense of operations, contents, and products. So operations, to be very simplistic about it, are just what the mind can do. Contents are what the mind can do operations with. And then products are all the different ways that the mind can show or tell the outside world what it did when it did those operations on those contents. So using a combination of theory-driven and factor-analytically driven thinking, Guilford came up with the idea that operations comprise cognition, memory, divergent production, and convergent production and evaluation. Contents comprise visual, auditory, symbolic, semantic, and behavioral material or stimuli. And products include units, classes, relations, systems, transformations, and implications. So if you put this all together, you have the idea that there should be, in a sense, about 150 different factors of ability, different types of ability. There's the cognition that you do on visual information and then represent or communicate as an implication. That's just one of, there are 149 other combinations you could make. And indeed, sometimes people have tried to represent this three-dimensionally by creating a set of cubes bunched together into a larger cube, and each individual kind of aspect or ability within mental ability broadly is defined by the intersection of these three different dimensions. So you can see one of the little cubes is being pulled out here. That's cognition operated on symbolic content and represented as a class. Okay, I hope that's clear. So the important point here is that SOI, structure of intellect, captures complexity, but arguably also suffers from complexity. Maybe it's too complicated to be practical, and ability tests really need to be practical. They were developed, or at least the ones we're going to focus on, are really all developed to serve practical ends, whether that's working in educational settings or clinical settings. So the idea of having a test which would have could assess 150 different abilities and then represent them, and you could use that information to create a report for a client seems daunting. And moreover, it's not like we have a really good way of measuring each of those 150 different possible cubes in the representation. So we've learned a lot, at least we learned to think in a more complex way from SOI, but it's difficult to put it into practice. So again, the important point or points to make here is that Guilford's model encouraged even more complex thinking about what mental ability is in a sort of a deep and structural sense. And just as an example of that, it's worth noting that most approaches to ability testing or intelligence testing focus on convergent production, that is, getting a single answer for a particular problem or item. And in some ways we could say that Guilford's approach encouraged or introduced the idea of divergent production, that maybe there are different ways to answer a particular type of problem. You could represent the answer in a variety of different ways, not just being able to, as is typically the case, verbally report a correct answer to a particular type of problem. So again, basic idea, important idea is it encouraged a more complex or maybe more nuanced way of thinking about what mental abilities are. And if you get nothing else from this model, this theory, it's worth keeping that in mind if you ever sit down to do an intelligence test or mental ability test with a particular client, thinking about the type of questions you're asking, the approach to testing that you're doing based on the test manual of the test you're using, and wonder at least to yourself, what are other ways that we could evaluate this person's mental abilities? What are other cubes or combinations that Guilford or his colleagues might have thought up? Anyway, if we transition a little bit, we'll switch now to the Cattell-Horn-Carroll, or CHC theory. This theory was developed by Raymond Cattell, who developed another, complex model of mental ability that was later expanded by John Horn and John Carroll, hence the name. Here, the idea is that intelligence is again hierarchically organized, and the numbering is slightly different than the previous numbering, but the idea is similar to the kind of the Spearman sort of Thurston idea that on one level, at the most basic level, which they call stratum 3, there's your pervasive mental ability, little g. Beyond that, there are a certain set of broad mental abilities, they call that stratum 2, and then even further above or beyond, there are narrow abilities, what they call stratum number 1. So you already know what little g is, or at least you have a sense of what it is. Let's take a look at some of those broad abilities proposed by the CHC model. So again, on stratum 2, level of broad mental abilities, we have, according to the CHC theory, fluid intelligence or reasoning. This is kind of high-level reasoning, the ability to inductively reason and abstract general principles or notice from stimuli to notice relationships. This is the sort of thing that we believe matrix reasoning tasks tend to really tap quite closely, or in quite large measure. Arguably, this is a relatively cultural-free type of intelligence or type of ability. It doesn't depend on knowing particular vocabulary, having particular cultural background. It's just, can you notice relationships, which maybe is something that's common to all people in roughly equal measure. Anyway, fluid intelligence, fluid reasoning, that's one mental ability. Another one, crystallized intelligence or knowledge. This is your breadth of knowledge. We have this idea that intelligent people just generally know more than people who are not very intelligent. So if you give them tasks like vocabulary tasks or sort of information tasks, the more intelligent people are just going to have more stuff to draw on to answer those questions. And this is obviously very culture bound. It depends on being part of a culture that is the same as the culture for which that test was developed, knowing particular vocabulary words because they're frequent in your language of choice, having particular understanding of history, and so on and so on. Fluid intelligence, crystallized intelligence. You certainly heard of those terms before. They're almost common in our regular language, but in terms of the CHC theory, they are broad abilities that exist in a sense, above or sort of it depends on how you orient it, whether you call it above or below, but let's say beyond G, or just general mental ability. Broad abilities also include specific domain-specific knowledge, so it's like your achievement in a particular area, not just your general wealth of knowledge, your crystallized intelligence, but just your knowledge in a particular area or topic. It includes visual spatial abilities, auditory processing ability, general retrieval, that is to say how well you can form and store and retrieve from memory, cognitive processing speed. So that actually sounds a little bit familiar to us from way back when with Galton and colleagues. There is still this idea that people who are more intelligent tend to work more quickly through information. And there's also decision and reaction time speed, a similar, although in this model, somewhat distinct idea or ability. So each broad ability, stratum 2, is related to multiple narrow abilities. So beyond that, and pick any one of those broad abilities and you can connect them out to many specific narrow abilities. Try and represent this pictographically. It might look a little bit like the following. Little g influences everything, and then there are those specific broad abilities which will influence performance on given tests, which are themselves related to or influenced by specific narrow abilities. So you can see all those little boxes towards the bottom of this picture. Imagine that for each one of those you have a separate test. You have a test of auditory processing. Well, that's going to be related to little g, it's going to be related to the broad ability of auditory processing, and it may have something to do with specific narrow abilities that are more like that particular test. So important points here. It may not be really obvious from the way I've presented it in these slides, but CHC represents a kind of a consensus opinion among people who do research and theory development in the study of intelligence and the study of mental ability, and also people who do research and test development in the world of, well, test development. A consensus opinion in that it seems to kind of capture what most people in that world more or less think the structure of mental ability is, what the different parts of intelligence or the parts of mental ability are, at least based on how we generally think about and test intelligence. Now, you could, as a side point, say, look, there are other types of things which some people consider part of intelligence: social functioning, creative thinking, etc., etc. Those are still somewhat distinct, and they're not well represented in these theories or in the tests that they have inspired. Because indeed, CHC has been, or is, or continues to be, a foundational part of most modern tests of mental ability. So tests like the Wechsler System and the Stanford-Binet were really influenced by CHC theory, indeed CHC theory is kind of invoked when those tests are interpreted. So if you open up the Wechsler Adult Intelligence Scale and you administer it and you score it up, it hopefully doesn't surprise you that that test gives you an overall or full scale intelligence. It also gives you broad intelligence in different areas, and then there is the ability to think about or kind of analyze specific test performance for each of those broad areas. Well, that looks not exactly like CHC, but very similar, and that's not by accident. It's because the test makers, Wechsler and later colleagues, were very much influenced by this particular kind of consensus position in the world of research and test development. Now, moving on, I'm going to hit just a couple more things, or a couple more theories. One is Sternberg's triarchic theory of intelligence. You've probably heard of this before. It commonly is discussed in like developmental psych classes, or maybe just even in a good intro psych class. So this may be familiar to you. Sternberg had this, in a sense, expanded our scope of thinking about mental ability. Recall I made the point way back at the beginning of this lecture that the focus or the scope of a lot of theory and test development has remained throughout most of the 20th century and even now into the 21st century rather narrow. And Sternberg and others sort of expanded that scope a little, or at least try to. And in the way he did this was he argued that mental ability has different types of what he called components. There's an analytical or componential, I always find that very awkward, component to mental ability. There's an experiential and a contextual element to mental ability. So if we try and look at these a little bit more closely, there's componential intelligence or ability, and this involves the awareness of and the ability to manipulate meta components, performance components, and knowledge acquisition components. And if that sounds vague, sort of what we're talking about is that kind of classic idea of fluid intelligence, or fluid mental ability, your ability to recognize pieces of information in the world and learn relationships about them and manipulate those relationships to gather knowledge about the world. Experiential intelligence involves your ability to learn new things and to make new operations automatic, what Sternberg called automation. And then there's contextual intelligence, which involves your ability to adapt to new situations, to select responses, shape your responses to be consistent or to be effective in new settings, to kind of roll with new settings or new tasks that you encounter. So I know this slide's a little bit fuzzy, but this is just an attempt to kind of pictographically represent what this might look like, the componential, experiential, and contextual components of intelligence. Now, what's the important point here? The important point is that the triarchic theory, again, kind of expanded the concept of mental ability to sort of break away a little bit from what was, kind of the traditional at the time notion of mental ability, expanding particularly to include this experiential and contextual aspect or component of intelligence, things that weren't maybe part of traditional approaches to testing, like solving practical problems. So I've shown this picture. It's a classic New Yorker cartoon in other lectures, but it kind of jokingly makes points towards this. The person who is the sort of forest dweller is saying to the guy who's either an explorer or maybe just a tourist something like, "You can't build a hut, you don't know how to find edible roots, and you know nothing about predicting the weather. In other words, you're terrible on our IQ test." There are other things about sort of practical problem solving that maybe are or should be part of the way we think about and test intelligence. And it's worth noting that triarchic theory has been embraced by educators, school counselors, and a lot of clinicians as well. I think probably because it gives them a way or a language or kind of a basis to describe different apparent types of ability and performance. Like imagine you're a school teacher, and I have kids. Every day I drop them off at school, and I chat a little bit with their teachers, and I think about what the teacher's world must be like, seeing many different children and having a sense that they have different types of intelligence. One kid seems very analytical, the other seems able to kind of come up with new ideas, the other seems very good at adapting to new situations. In fact, it's notable that if you do like a Google search of Sternberg's triarchic theory of intelligence, you often come up with those three components except slightly renamed. So experiential intelligence is often called, at least in the pictures and a lot of the websites you find, creative intelligence. Contextual intelligence is often called or renamed practical intelligence. I'm not exactly sure how or when this renaming occurred. I don't think it's kind of consistent and canonical with Sternberg's real theory. Rather, I think it reflects a desire by some people, especially educators, counselors, etc., to expand what we mean or what they mean when they talk about intelligence or talk about different styles or types of intelligence. Just as an example, this is just some almost at random picture that I pulled down when I did a Google image search for Sternberg triarchic theory. So you can see here this idea. There are three components of intelligence: creative, analytical, and practical. The validity to this claim, I think, is a little bit open. Sternberg's theory is a lot of theory, and how well it can be put into practice and tested and thus evaluated is unclear to me. But I think it's worth acknowledging this does reflect a desire that people have in the world to think about intelligence this way. Again, maybe especially educators, and maybe also just kind of a commonsensical notion that many of us have about what smarts or intelligence or mental ability are. There's this seemingly kind of, I don't know, almost nerdy analytical ability, and there's that kind of sort of free-thinking creative thing that people can do, and there's also that real sort of let's get down and solve the problem practical thing that people can do. And it seems like all of those things, those three components, those three aspects of intelligence, all should be important. Again, not to drill down too much or to sort of criticize too much Sternberg's theory, it's worth noting that analytical component, or the analytical component, is the only one that we have really good tests and norms for, because it's the one that looks most like the type of intelligence that we have all along, and well, at least all along in the 20th century, been thinking about. That kind of school-related ability, your ability to learn information, but the type of information you typically learn at school, or the fact that you have already learned that information. In one of my lectures, I jokingly called intelligence schooliness, but in a way I think that's an appropriate word. It's weird, and it's a neologism, of course, but it's an appropriate word for describing the thing that intelligence testing tests. It's how good you are at learning in the type of environment that many people, at least in modern Western culture, have access to, which is schools. Again, is this the only thing intelligence is? Some people, Sternberg and others, would certainly argue that there's more going on there. What about these other components, experiential and slash creative or contextual slash practical? They seem important, and they are an area of future test development. Back when I used to teach this class a few years back, I used to do a separate set of lectures on creativity testing. And if you're enrolled in my class now, you know that there's a chapter in your textbook that talks about test of creativity. I cut that out just because there wasn't a lot of time in this short semester to cover it. But there are people, currently there's a lot of interest in developing theories of creativity and test creativity. This is hard work though, and as an illustration of that, imagine that you were trying to develop a test of creativity. What would that test look like? How would it be scored? How would you gather norms to evaluate any particular person or particular student's responses as compared to what would be expected from her based on her age or her level of schooling or some other factors which might be important? Arguably it's a tough challenge, but not a challenge that people are shrinking from. There are a lot of people working in this area. So I've covered a few different theories of intelligence. There are other theories that I didn't cover. So I didn't talk at all about the planning, attention, simultaneous, successive theory or pass theory. I gave it a pass. I didn't talk about information processing theory, although we'll talk about that a little bit later when we get to neuropsych testing. Didn't talk about Gardner's theory of multiple intelligences, which you probably remember from like a developmental psych class or maybe even a good intro psych class. Mostly I didn't talk about these because we don't have really good ways of testing. These are theories which haven't yielded good practical tests. And we're a class that's interested in practical tests, and this is a lecture where I'm about to start talking about real practical testing. Most of these tests most of these theories don't have good tests, at least yet. It doesn't mean we should ignore them, but it means we can't really use these theories, at least not clinically, because our tests, like I said already, they need to be valid, they need to be reliable. That's hugely important. They also need to be practical, as in you could administer these in a hospital or in a school or in a clinic and so on. Pardon me. And with that in mind, let's talk about some specific tests of mental ability or intelligence. Well, the first one I'm going to focus on is the Wechsler Adult Intelligence Scale. There's also in the Wechsler system the scale for children. I didn't put it up here, but there's a scale for infants in the Wechsler system. There's the Stanford-Binet, which I will talk about. The Detroit Test of Learning Aptitude, which I did not include. There's a Kaufman Assessment Battery for Children, and the Kaufman Brief Intelligence Test, the KBIT, which I used to talk about, but I don't in this class anymore. Interesting observation. Total scores on most of these tests, if you kind of match them for their overall score, like someone's full scale score on the WAIS versus their full scale score on the Stanford-Binet, those correlations tend to be pretty high. They're as high as test-retest correlations for each test themselves. So you administer two different versions of the Stanford-Binet, you administer the Stanford-Binet and the WAIS, you get the same, across a large group of people, you get the same range of correlations. Which suggests that overall these tests are probably measuring the same thing that we call intelligence or mental ability as it's operationalized on intelligence tests. And in a way that's interesting or cool. In a way it's not super surprising because many of these tests actually look a lot alike each other. Once you learn one of them, once you learn the WAIS, it's not that much harder to kind of learn the Stanford-Binet or vice versa because they look, although there are some differences, they look fairly similar. So one thing that's interesting about these modern tests or these current tests of mental ability, intelligence, is that they tend to be fairly correlated with each other. Maybe, probably, because they're all measuring kind of the same thing. They certainly share a lot of the same measurement approaches, so maybe some of it goes down to measure variance. Another interesting thing is that all of them don't just produce a total score. So yes, you can get a full scale IQ score from the WAIS, but you can also get scores based on subsections of the test, specific tests which group together, which represent areas of intellectual functioning, or maybe, indeed components at kind of a structural level of intelligence or mental ability. And that's not by accident. It's because these tests were all developed based, at least in part, on some of those theories that I've talked about already, especially the CHC theory. There are some significant differences between the tests. which you could kind of pin down to different theories of intelligence or different applications of those theories, but for the most part, they are fairly similar. An important point here is that a skilled test administrator needs to understand some of these differences between the tests, understand a little bit about the differences in their theories and their applications, so that he or she can choose the right test for a particular referral question. Okay, so let's move on. We'll talk a little bit about the Stanford-Binet intelligence scales, basically the Stanford-Binet test. Here's a classic picture of an old test with some of its original materials. Somewhere in the Department of Psychology at NDSU, I swear we have some of these components still. What's the history of this test? Well, it's the longest running test of intelligence. It was developed originally by Binet and Simon back in 1905, but it's been revised significantly over the years. It's currently in its 5th edition. Early editions had only one score, the sort of a composite IQ score, although subtests could be analyzed in a kind of impressionistic way. Indeed, Binet kind of argued for a somewhat impressionistic interpretation of any individual's test. However, later tests, as was the case with the Wechsler test and others, expanded to include formal analysis of different components on the test, so you could get at perhaps different components of intelligence. So what does the Stanford-Binet look like? Well, it gives you a full-scale IQ score. It also gives you 5 factors in intelligence that are based on cognitive theories of intelligence, including Carroll, of CHC fame. Also Baddeley, who's a intelligence and memory researcher who you may be familiar with that name from other classes you've taken. But suffice it to say, there's a particular theoretical focus here. It's rather cognitive in nature. And each test, each factor of intelligence can be assessed in 2 different ways, a verbal way and a nonverbal way. This was a relatively speaking recent addition to the Stanford-Binet system, in part because of the influence of the Wechsler tests, which were designed to have this rather verbal and rather nonverbal component to them. So, 3 scores: full-scale IQ, verbal IQ, nonverbal IQ. Again, note that kind of connection to the CHC theory. 5 factor scores: fluid reasoning, knowledge. You might want to call that, fluid reasoning might be like fluid intelligence, knowledge might be like crystallized intelligence, quantitative reasoning, visual spatial processing, and working memory. Note the kind of the hierarchical structural nature of this that's similar to most other, that relates to or draws from most major theories of intelligence and is similar to other tests of intelligence. So if you try to sort of put this all together, you could see that we've got 5 different factors of intelligence, each of which can be assessed verbally or non-verbally, and in aggregate give us a kind of a full-scale IQ. So that's kind of a neat thing about the Stanford-Binet, is it allows you to very easily produce this kind of verbal intelligence, this non-verbal intelligence, but also talk about any specific test, any specific factor in 2 different ways. That's in some ways more nuanced than the WAIS or the Wechsler system that we'll talk about in just a few more slides. Interesting or special features about the Stanford-Binet scales? Well, there's a routing procedure. This test is designed to be usable for people across a very broad range of ages. You only need one test. You don't have multiple different types of tests like you do in the Wechsler system. So the routing procedure is kind of like a pre-test that allows you to select the appropriate entry point to start a given client at based on his age or her age and mental ability. So you don't have to start at the simplest questions that all the adults are just going to get super bored with because they're way too easy, or nor do you skip ahead far too far so that the children are all really confused. It's useful for screening. It helps you select an appropriate level. It helps you skip items that are too easy without losing validity of the test. Interestingly, this approach is based on item response theory, psychometric theory that I haven't actually talked about as much as I really should have in this class, although I'll do probably a little supplemental lecture on it later. Other special features, well, this is kind of technical, I suppose, but the Stanford-Binet 5 current edition includes more difficult items than its predecessor, the Stanford-Binet 4. This gives it a higher ceiling. So it basically kind of you can go higher on the test. You can have, it can be useful for testing people who are intellectually gifted, more so than could its predecessor. It also has a lower floor. It includes more easy items, so that means it's more appropriate, or it's more usable with intellectually challenged clients, and it can be usable with children as young as the age of 2, which is pretty amazing. Like, I don't have a lot of experience in this personally, but I do remember a couple times running Stanford-Binet tests with really young children, like kind of 2-3 years old. And it's pretty amazing that just one test allows you to go from basically almost as young as you can possibly get people to about as old as you can possibly get people. You know, it gives you a very broad range of assessment all in one test, unlike the Wechsler system, where you have to have, there's a separate test for infants, the WIPC, a test for children, the WISC, and a test for adults, the WAIS. Another nice feature about the Stanford-Binet is this ability to measure nonverbal IQ, which can be practical in situations where you're working with non-native English speakers or with clients who have hearing or speech problems. So the idea here is that for any of the factors that we've previously talked about, or I've previously talked about, you can test them just using the nonverbal components, or the nonverbal tests for those components, which again could be handy if you're working with someone who doesn't have as much expressive language ability as you would need to get a valid assessment using all the tests on the Stanford-Binet. A couple more, or really I think one more neat feature. It's a test which has been, in its current form, been fairly rigorously examined for test bias, including things like religious bias. So it really has been scrutinized to see whether items on the test are easier to answer if you're a member of one ethnic or cultural religious group as compared to others. As far as I know, this is the first test, the Stanford-Binet, to do this level of really fine-grained sort of cross-cultural testing and comparison. And it's probably about as fair as you can get in terms of intelligence testing or mental ability testing across different cultures. Now, that being said, like all tests of intelligence, it is very much rooted in the measurement of things which are important to schooling, especially schooling as it's, you know, thought of and practiced in the modern and mostly Western world. So it's not exactly a culture fair test or culture free test, but to credit the test makers, they've done a lot of work to try to remove as many sources of potential bias as they could. One more special feature, the working memory factor is sometimes used on the Stanford-Binet for assessments of ADHD. I'm honestly not sure why I included this slide in this lecture, because if you were assessing ADHD, there are probably better, more formal ways to do it. And we'll talk about those a little bit later, especially in the unit on neuropsych testing. Okay, so that's the Stanford-Binet test. Now I'm going to move on to the Wechsler Scales, or the Wechsler System. The Wechsler System is a very practical testing system that was designed to be suitable with a relatively diverse population. It was originally developed by David Wechsler during his time working in a psychiatric hospital, and he wanted a test that could be used at bedside. It didn't require as many pieces of equipment or little items to manipulate as did the Stanford-Binet. If you sort of flash your mind back or rewind this video back to the little old school Stanford-Binet kit, you would see, or you can remember, that the Stanford-Binet used to and still does have just a lot of stuff in it, and it takes relatively somewhat longer to administer the test, and it's a little bit fussier. Wechsler wanted something that was simpler but still valid. And in fact, he drew a lot on the Stanford-Binet when developing the Wechsler test and on the Army Alpha tests. He had been part of the testing effort during World War I and other tests that were available at the time. Again, he wanted an alternative to the Stanford-Binet. He wanted a test which wasn't quite so kiddie-like. It didn't have so many little toys in it. It would be more appealing to adults, I suppose. At the time, the Stanford-Binet had too many word manipulation items, so it was a very verbal test. That's not so much so now. It also had a lot of timed items. That's not so much so now. Also, at the time, the Stanford-Binet used a system for measuring intelligence that involved measuring mental age, and that kind of didn't make sense for adults. So recall that originally on the Stanford-Binet IQ intelligence quotient was literally a quotient of your mental age, how well you did on the test, divided by your chronological age. If you did much better than we would expect for your age, you've got a high IQ. If you did much worse, you've got a low IQ. Usually that quotient is multiplied by 100 to get rid of the decimal. But anyway, what Wechsler, why that doesn't work, of course, is at a certain point, and believe me, at my age, I know this, your chronological age is going up, your mental age doesn't seem to be going up. In a sense, your IQ goes down the older you get once you leave school. The Wechsler test kind of didn't invent this, but kind of enacted or made practical the idea of an expected score. So IQ was on the Wechsler system, and the Stanford-Binet later adopted this as well. A quotient that represents the relationship between how well you do, your attained score, and your expected score given your age. So for people of a particular age range, 30 to 32, we expect our norms for that group are that people get a certain number of items on this particular test right. If you do more than that, then you're doing better than average for your age. If you do worse, you're doing worse than average for your age. Depending on how you do across all the different tests all the different subtests on the overall battery of tests, then maybe your IQ score is relatively high. Maybe it's relatively low. The WAIS, or the Wechsler system, the WAIS is the Wechsler Adult Intelligence Scale within that system, also kind of pioneered this idea of two main subsections, a verbal and a performance subsection, a kind of a verbal IQ and a performance or a nonverbal IQ. That idea was later adopted by the Stanford-Binet system as well. Now, Wechsler originally developed this idea of two main subsections, a verbal and a nonverbal or performance subsection, because there was at the time this idea that discrepancies between the two were diagnostic of different sorts of neurotic or psychotic disorders. And research then, and certainly research now, doesn't really support this, but it can be useful for clinical applications. I mean, it can be kind of interesting to note that a particular client does much better on nonverbal sort of performance subtests than they do on the verbal tests. It might suggest that those verbal tests are in a sense an underestimation of what their overall mental ability ought to be, maybe because they have poor language ability, maybe it's because their English is not their first language, maybe it's because they feel anxious talking. There are possibilities that you as a clinician might want to explore. And as I've noted already, this idea of like a verbal and a nonverbal intelligence, it wasn't really invented by Wechsler, but it was put into practice on this test. It's been copied by other tests, including the Stanford-Binet test, which really copied it and expanded on it even more than did the Wechsler system. So on the Wechsler system, on the WAIS and its sort of brother and sister tests, you get a full scale IQ, so that's little g. You also get 4 index scores of intelligence that were based on current theories and kind of tradition within the Wechsler test. Especially when I say current theories, I'm really talking mostly about the CHC theory of testing of intelligence or mental ability. And those are verbal comprehension, perceptual reasoning, working memory, and processing speed. These don't map exactly onto those theories that I talked about earlier, but they're somewhat similar and kind of consistent with those theories. Special features, well, this is really the gold standard of intelligence testing. It's widely used, more widely used than is the Stanford-Binet, so that's the reason why we tend to teach it in classes. It's a part of a family of tests, so there's an adult-child version of the test, there's an infant version of the test. I didn't include that in this slide. There's also a memory test in the Wechsler system called the WIMS. There's an achievement test in the Wechsler system called a WIAT, and they're all developed at the same time, or they're all kind of updated at roughly the same times, so they have common norms, and you can compare someone's score on the WAIS to their score on the WIAT, and you can feel pretty comfortable interpreting discrepancies because the norms published in those respective test manuals are from the same people, or from the same population in the standardization sample from those two tests. So just an important point to finish up on. These two tests, the Stanford-Binet and the Wechsler, are practical implementations of modern theories of mental ability, especially the CHC test. And so they give us this kind of full-scale IQ. Then they also give us this sort of a structural hierarchical organization of components or abilities. They emphasize verbal and nonverbal abilities, and they also have other components that seem important, like memory or processing speed. So they're not exactly theory driven, they're theory informed, they're practical, and they reflect a little bit about this sort of the ancestry, their background in terms of there are theories on what it means to be intelligent or have high mental ability. Whoa, hopefully by this point in the lecture you feel a little bit more intelligent, or at least not too worn out by listening to me talk all this time. Take a break, have a cup of coffee, have an espresso or something to perk yourself up. Hopefully this all makes sense to you. If it doesn't, please let me know. And as always, thanks for your attention.